Today the focus is on hypothesis testing. Before we start the course, let me grab your attention by telling a small story. Okay, I have two cups. One cup holds coffee, the other holds the same quantity of milk. And 1 century ago, a lady claimed that he can testing the difference between two make-up of milk tea. One is tea, one is milk. One is pouring milk into tea. The other way is to pouring tea into milk. Okay. Then many scientists at that in that afternoon's picnic laughed at her because these people are chemists. No, they know no difference between the two mixtures, and you can't tell without seeing the mixing procedure. But fortunately, there is a great statistician named Ronald Fisher, and Fisher thought, wait a second, I can test whether this lady was lying or not by designing an experiment. Now, assuming this lady was purely guessing, then he had only 50% to guess it out, right? Then let's make up 10 mixtures, 10 cups of milk tea. What's the probability for that lady consecutively guess correctly for all the 10 cups? What's that probability? 2 to the power minus 10. Am I right? That is and today we know it has a jargon. It is p-value. Okay? So p-value and experimental design starts from that lady tasting tea. So there is a very good book called The Lady Tasting Tea. I highly encourage you to take a look at that book. It tells the whole history of the last century's evolution of statistics and biostatistics. So today, we will introduce several influential distributions, probability distributions for a binary random variable, for a count random variable, and for continuous random variable. And then the most exciting part of the journey will for us to learn the philosophy of modern scientific research. And the core part of it is test and hypothesis. So a random variable, it is a quantity. It is a quantity whose value is not fixed, but varies according to a probability distribution. For example, we have a binary random variable like admit to a graduate school or not. It's binary. And a systolic blood pressure is a continuous random variable. Number pregnancy is a discrete random variable. Okay, so the first important distribution, the very popular one we encountered, is a discrete distribution describing the number of successes in a sequence of n independent yes or no experiments. Each of these experiments, we call it Bernoulli trial. A Bernoulli trial. Bernoulli is the person who found this distribution, actually. And the probability mass function tells us the probability of seeing k, small k, seeing k success out of n trials can be formulated this way. You don't need to remember the formula, just knowing that its nature, okay, definition. And here, on this plot, we draw the probability mass function for two binomial distributions. One describe an experiment with 20 trials, and each trial you have 80% success. And another one describe another experiment with 10 trials, and each trial the success probability is 20%. It's just you threw uneven coin, okay? 20 times or 10 times. One coin has 80% heads up, the other has 20% heads up. And then you will see this distribution shows the probability of seeing no heads up is like 10%. The probability of seeing like 3 heads up for the second experiment, the experiment with the 10 trials, is like 30%. So in that situation, you have a highest chance to see 2 or 3 or 4 heads up compared to seeing 0 or 5 or larger. You know, that tells each, if you sum the heights of each bar for each distribution, the total will be 100%. Okay, that's the definition of probability mass function. Remember, this is for 2, okay? We only encounter one of them. And the second important distribution is called Poisson distribution, named after that mathematician, Poisson. He's a French, probably. I forgot. But that describes the probability of a given number of events occurring within a fixed interval of time. For example, in 2010, we collect the data from 121 hospitals in California, and we can measure the number of deaths after a certain heart surgery, coronary artery bypass graft surgery. Okay, after surgery, within 30 days, how many people died for each hospital? That number is a count. Must be non-negative. Okay, it could be any number starting from 0, and it must be an integer. Its distribution for that kind of variable has this probability mass function. Again, we only need to take a look how the shape of this distribution. Of course, when the mean number of deaths during that 1 year is low, you will have a higher probability seeing, you know, an outcome that is the number of events low, and you have a smaller high probability to see larger number. In California, this annual rate of mortality rate was about 2.5 to 3%. You know, so this red distribution probably describes that process fairly well. But when you see higher chance or expected rate of mortality, then this distribution will shift from the left to this blue. You know, this corresponds to 1, 5, and 10, different level or different. And the third important one, we already know it. It's a normal distribution, invented by Gaussian. Gauss is how to pronounce Gauss or Gauss is one of also another French mathematician. And for the continuous random variable, we don't have probability mass function. Instead, we have probability density function, because within a because that random variable is continuous. It could be any single value within a range. You know, so we can only see the density, define the density of that distribution. By that we mean that you can calculate, like under this curve, what's the probability for a value between -4 and -3. You can sum this area under the curve, and that is the probability of an event with a value between that range. You really can't see that the probability of seeing a value exactly equal to -3 is like 20%. It doesn't make sense. So here, this picture shows 4 normal distributions with different parameters. We have 2 parameters for normal distribution: the mean, that is mu, and the variance, sigma square. Okay. So when we derive a new variable called z, z is a very popular symbol we will encounter in biostatistics. Z usually refers to the random variable minus the mu, that is the center. X minus mu, that means we centered our data, so that the mean is always 0. Am I right? And then you divide this by the standard deviation. Then by doing that, we standardize or we normalize our random variable, so that its distribution will be like this green one. That is called standard normal distribution, which has 0 as the mean and 1 as the standard deviation. As we already introduced this great guy, this guy almost single-handed developed the modern statistics by himself. And another very famous figure is named Carl Pearson. Carl Pearson, we all heard of a chi-square test and chi-square statistics. That was invented by him. And he also, together with another famous guy, Niemann, developed the paradigm of hypothesis testing. The other guy is named Galton. Galton introduced the correlation statistics. And Gaussian, all these 3 figures related to genetics, because they are not only statisticians, they are more probably famous for their contribution to biology research, especially related to genetics. And this guy is a half cousin of Charles Darwin. You know, so these 3 all together using statistics to prove the natural selection hypothesis all their life. So they are famous for their contribution to the modern biomedical theory. And now we want to introduce a very famous book written in 1959 by Karl Popper. This was probably one of the most influential books for the 20th century. It described the logic of scientific discovery by claiming that a scientific statement should be what? Falsifiable. Falsifiable. What does that mean? That means a statement like this, all sheep are white. That is a scientific statement because you can bring a black sheep to reject that statement. Okay? But that statement itself is very, very difficult to prove because you cannot search all over the world for all the sheep you see and make sure they are white to prove this. So scientific research, the key is to formulate a falsifiable statement. And then a researcher's task or mission is all through the career to seek for that black sheep. You know, that's the idea. To seek for that black sheep by either developing experiment or collecting data. Okay? That means find evidence find counter examples to reject that statement. Then you will be recognized as a contributive scientist. That's all. There is no people from now you should claim what I adopt is absolutely the truth or correct. It's every statement is like a kind of approximation toward ultimate truth. And all our career is to modify that scientific statement or modify our available scientific theories, okay, or to improve them by our own unique finding from our own designed experiments. So, another famous book in 2010, it was, you can see the 14th edition, okay? That tells the introduction to, that introduce to the basic theories related to logic or reasoning. It tells about how inductive and deductive reasoning, those theories, be tangled with the pathway of scientific research. Okay, so you may have to go through these 7 steps, in order to be a notable scientist. And one of the core is test your hypothesis. So the first step, the first stage is to formulate your hypothesis and then collect data to test it, and then you can publish that. Okay. So hypotheses, as we have seen, they are assertions that are capable of being proven false. Okay, using a test based on the data you collected or observed. And null hypothesis is a choice of general or default position. Okay? For example, when we develop a new drug, FDA will define H null is a default to resemble non-hypothesis. Okay? FDA's H null is the drug has no effect. Okay, that's the H null. So you formulate this null hypothesis, and then a developer or a drug developer's mission is to collect the data to reject that null hypothesis, so that he may use a randomized clinical trial to suggest that this drug, at least for these studied people, has effect, because our data can reject that null hypothesis. Okay? Again, here you see, a potential treatment has no effect. Can you really prove it? Probably you can. Or you may never prove that a drug has effect. Why? Because unless you can apply that drug to everyone in this world and see no effect, even though in the United States you didn't see the drug effective for people, but maybe one day if you carry that drug to the people living in the mountain of Himalaya, it works for them. So you really can't prove H null, but it's easier to reject H null. That's the philosophy. I think the philosophy comes much more valuable than the formula you need to remember or calculate, because our job and the computer's job and the software package will help you do that. All you need to remember and to be very clear with the logic why we develop hypothesis testing this way. Okay? So an alternative hypothesis will be the more desirable, because it's just like the black sheep. For example, that is for the drug company. Drug has efficacy because I used 1,000 people and I applied a t-test, we will see later, to reject this H null, so that you can approve my you can approve my drug and market it. We can, that's the whole idea. Okay, that's the reason behind that, behind this thing. All the logic is the key to understand. Now let's come up with the practical procedure of conducting hypothesis testing. So it is a decision-making process. A researcher's decision is to either reject H null or accept H null, or either rejected H null or accept H null. You only have these two options. When the H null actually is true, okay, this is when the H null is true, when you reject it, you made an error, you make a mistake. That is called type 1 error. What that means you have a chance to approve a fake drug because H null here is a drug has no effect. Am I right? Use this to remember. Use this example to remember this. The H null is defined as a drug without efficacy. But you reject H null means you claim this drug has efficacy, but it does not have efficacy because H null is when H null is true, then you make a mistake. That mistake is terrible because you send to the market of some toxic chemical that does not work and let your patients take it. That's horrible because the damage is hard to undo. But on the other hand, when the drug does have effect, you didn't reject it. You accept H null. What does that mean? That means you make another error labeled as type 2. That means the company missed an effective drug. That's a kind of a regret. Okay? That's a loss to that pharmaceutical company, but that does not generate damage too much to the public. So we have to control type 1 more than type 2. Standing from the point of view of FDA and the public wealth. Using another, life is full of regret. Why? Because imagine you are an investor, you purchase your stock, you are a capitalist, you want to invest into small companies. Type 1, what does type 1 mean? Type 1 means you invested into a company, but that company didn't grow. You lose your money. Type 2 means there was a small company and the owner of that small company named Serge and Page. Okay? They came to you to ask you for money. You said, what is search engine? I don't like it. You miss it. Then 10 years later, you feel regret. That's type 2 error. Okay? That's all you need to remember today. Type 1 error, type 2 error. If you agree with me, the fundamental law governing our universe are probabilistic, then who can avoid making one of the errors? Nobody. All we can do is to reduce them, to control them, so that we make smaller number of mistakes compared with other competitors. Then we win the competition. Am I right? That's a philosophy, not only for biomedical research. So significance level, we sometimes use alpha to resemble significance level for a hypothesis testing. It is a probability. It is like a cutoff. It's like a cap we put there to guard against the type 1 error by setting its probability that we can tolerate For example, we can set the significance level at 5%. If your experiment with a hypothesis testing result, a p-value, later we will introduce the concept p-value, smaller than 5%, that means the type 1 error is smaller than 5%, then we will pass your drug and market it. Otherwise, not. Okay? So we constrain the type 1 error by this cutoff, 5%. We call it significance level. So any testing, if people see there is a significant difference, that means the chance or the risk of type 1 error is smaller than 5%. Okay? It does not mean the drug is absolutely has effect. You still may have 5% chance marketing a big drug. So p-value is defined as the probability that is seeing a difference or effect that big just by chance under the null hypothesis. Assuming this drug has no effect, we randomize 2,000 people, 1,000 with this drug, 1,000 with the placebo. Later, we measure their mean drop of body weight. Let's assume this is like a body weight, control drug, a diet. After 2 years, we found the diet associated with a mean value of 2 pounds loss, more than the placebo. In that situation, assuming this diet has no effect, what's the probability of seeing a mean value 2 pounds higher than the placebo? What that probability is? The probability is only 1%, for example. That means, given that there are really no effect, no difference between the two arms, the chance that we would get a data as extreme as ours, that is 2 pounds or larger, in the treatment group compared with the placebo, is the chance is only 1%. It's just like you give the 10 cups to that lady. If that lady correctly guessed out all the 10 cups, if you still starving and claim that he's by guessing, that chance he guessed out 10 cups without error is only 1/2 to the power of 10. It's much smaller than 1%. Do you still be starving? If you are still be starving, nobody can argue with you. So that's the idea of p-value. Okay. So a testing procedure consists of following 3 or 4 steps. First, you need to state the null hypothesis. Then look at the data and decide an appropriate statistical test depending on the format of your data. For example, your endpoint may be like a binary. Then you may use binomial distribution. Okay? If it's continuous, then you may using normal distribution or t-distribution. We will see that later. Okay? Depending on the data, the format of your data, measuring the endpoints or the outcome of your treatment. And then you compute the statistical test. That is, you construct a statistic, which is a summary of your data. For example, the mean from one group minus the mean from another group. Okay? That is the statistics. And then you check which distribution that statistics follow. It may be like a t-distribution, as we will see now. Okay? If your t-test, your data, you form a t statistic, and using a t-distribution, from distribution, you identify your p-value. You can calculate your p-value. If the p-value is smaller than 5%, all our company's employee will have a bonus today. Yeah, that's the people making money in the pharmaceutical companies. All depend on p-value. You know. So, for example, here we're using this GRE data, the admission data. We formulated a non-hypothesis, that is, the mean value of GRE for the female is equal to the mean value of GRE score for the male people, for women versus men. And we will, because we have the two group data here, we can summarize the mean GRE from the first group and also the mean GRE from the next group. Then the difference ideally should be 0 if H0 is true. Am I right? If the difference between the mean difference is far from 0, that provides us some strong evidence in rejecting this H0, suggesting that there is a difference. That's the philosophy. So this difference, depending on the scale, some tests using scale like up to 800, some tests maybe up to 100. So you need to normalize this difference by dividing a standard variance of this difference. So this difference, x1 bar minus x2 bar, has a variance. That variance is formulated this, okay? Assuming we have unequal sample size, okay, N1 versus N2, we have different number of people, different number of women and men. Second, equal variance, which means the variance of GRE in the main group is equal to the variance of GRE scores in the women arm. Okay? That assumption, you have this formula. If the assumption is not correct, you have many other different formulas. Okay? My job is not to help you remember the formula. Okay? The interesting thing is this T has a distribution called student's T distribution. Your homework is to find who is the student. Okay? Yeah, because it's called student's T. Why not your name's T? Okay, so you search Google to find who is the student and tell us next time. So you will see that as the degree, T has a degree freedom. It's wrong here. It's a degree freedom like 8, 18, 28. 18 and 28. When the degrees of freedom goes to be large, toward infinity, it approaches standard normal distribution. Okay? So when the sample size, here the degrees freedom is, you can approximately treat it as like the total number of people in sample size in the data. That is 400 people in our data, minus 2, because you have 2 groups. Okay? So it's 398. Very, very large. Our degree freedom for the T is so large that the distribution of it is almost identical to a normal distribution. Okay? So, but for small sample size, there is a difference. Okay? Because the T distribution usually have a fatter tails on the two sides compared with normal distribution. Okay, that's it. So we're using a software package called R. If we have time, I show you next class what R look like. Okay, this is the result. We have a T like a minus 1.36. This is for the female minus the male to get and divided by the standard variance of that. So the degree freedom is 398. The p-value is 17% higher than 5%. So I think our audience should feel relaxed now. You know, it's especially for the ladies. You know, so even though the sample mean is a little bit higher in the sample for the guys, but not significant. Okay, so. And we also have conducted an F-test for comparing the variance, indicating the variance are fairly equal between the female and the male groups samples. Otherwise, we can using Welch two-sample t-test. I also did that. The p-value is 16%. No much difference. Okay. So let's revisit the definition of p-value. What does the p-value mean? P-value means if this is like a t-distribution or very close to a normal distribution, let's use a normal distribution for illustration. If we find that the t-statistics have a value 1.36 or minus 1.36 or more extreme than this, which means under the null assumption, the null assumption is there is no difference between the two groups. All right? So the center should be 0. Okay? Under this null distribution, any value should fall on the x line according to this density of probabilities. Now, you can calculate, as we know already, any value higher than 2 or 1.96, actually approximately 2. Okay? Just remember 2. Any z value larger than 2 or smaller than minus 2, the area, the sum of these two tail areas is 5%. Remember that. Okay? And our statistics, t-statistics, valued at 1.362 minus 1.362. Okay? And any area to the left of this and the curve and the total area, like this area, the sum together equals to 17%. Okay, this is a two-sided test. Okay, a two-sided test means we are not interested in whether boys have a higher score than girls. We just want to see whether they are different or not. It may be like boys are significantly higher than girls, or girls are significantly higher than boys. That's the reason we sum this area with that area. So long as we see a extreme value to some larger on this side or larger on the negative side, we will reject the null hypothesis, indicating there is a difference. We don't matter the direction. Who is larger? Okay, that's the two-sided test. But in many situations, in other situations, some situations actually, people may formulate the hypothesis test to do one-sided test. Okay, they only want to FDA only want to approve a drug, you know, with one-sided test. For example, the drug can help people compare with the placebo, will help you lose more weight, you know. Otherwise, if the placebo helps you lose more weight, there's no meaning to market that diet, you know, treatment. Am I right? So you see the two side, one side. But the idea is this. So for all other tests, it follows the same procedure. Find your summary indicating evidence to reject that null hypothesis. See what distribution that summary or statistic follows. And then check the table or use a computer to calculate the p-value. If it's smaller than 5%, your job is done. Otherwise, you still have to publish it, okay, as a fact. So another thing, as we see earlier, compare women with men. The admission rate, 24% for women admitted, 36% for men. It seems 36 is much higher than 24%. Okay, that seems that there is a correlation, association between gender and admission. These are two variables, admission and gender. If they are independent. If they are independent, in other words, we will see that the admission or not does not depend on gender. Otherwise, there is association. That means there are certain kind of unfair things happen. Okay? To do that, we use a statistics called chi-square, formulated like these counts, like 109 in each 35 in here. Those are the observed number of applicants that declined, that who are women. 35 who are admitted, who are women. Things like that. Those are the all observed count. Minus these each in the preferences in these brackets are the expected value. What does that calculate from? For example, 98 equals to what? Equals to 36% times 68% times the total number. 36% is the proportion of women in the sample. 36%, that means 144 women total, divided by 400, 36%. Marginal proportion for the women. And 68% is 273 over 400. That's the proportion of decline. So when these two times n, that is 98. That means assuming these two variables are independent. What's the joint distribution? The joint distribution is the product of each marginal probability. So then any discrepancy for the observed cell counts from the expected cell counts will indicate some kind of shifting away from your null hypothesis. So that one, similarly, what I show here is for different kind of parameters, we have a chi-square distribution. Chi-square distribution can be in any one of these shape, big shape, because it can have different degrees of freedoms. The degrees freedoms here for this two-way table, it's a R by C table. The degree freedom is calculated R minus 1 times C minus 1. So in our study, it's 1, because 2 minus 1 times 2 minus 1, 1. So we will, using this, if we calculated our statistics and found our statistics is here, then you can calculate the p-value using the computer, which is showing as the area under this curve to the right side of x. Okay? Which means assuming there is these two variables are independent, how far, how extreme, I see a discrepancy as large as that or larger. You know, that is, if that is small, you will reject it, and we're very unlucky to see that the p-value is 2%. You know, you can publish a paper seeing that it's not fair discrimination against women. After you published it, then the school, the 3 graduate schools hired me to reanalyze the data, to defend themselves. Okay? And they are lucky to see that, you know. Your homework is to search the Google for this term called Simpson's paradox. Okay? Which means I analyzed the data, found that those two group people, they tend to apply for 2 types of fields. One more related to natural science, like math, like chemistry. The other group area more like liberal arts, you know, all kind of social science things. And we found within each field, let's see, A and B. Okay, in each field, for example, in field A, this is the very few female woman applied for, because that's related to math or something women may not like. Okay, I'm not discriminate you. Okay, sorry, it's imaginary. Okay, I imagine. Okay, yeah. And you see that 62% for women be admitted to that field, versus 56 women in applying to that field had a higher admission rate. Let's see the other field, B. We only have two fields, okay? Either A or B. In B, wow, 19.5% for women be admitted. Only 12% for men. Still favoring women. What does the discrimination come from? You know, you ladies are favored, you know, in this. Although for each one we can conduct a chi-square test, but the p-value all larger than 5%. So there is no significance suggesting that either field women have a higher significantly admission rate. Okay, so the case is dismissed. But I wasn't paid. So it's here. You search this term in the Wikipedia, you will find that case. That is the case in 1976 at Berkeley. Okay, you will find exact number, but different from this what is made up here. Okay, there is a true thing. You can, from there, you think about why this paradox happened, which means that in many situations, if you treat your computer and me as like a black box, you can get a p-value to make you happy. But whether that p-value is justifiable, it's really depending on your knowledge and scientific background. So your knowledge cannot be replaced by any computer or statistician. So, and if we compare GRE between not only two groups, but now how about institutes? Not 4 institutes, but 4 groups of institutes. Their rank of 1, 2, 3 is like a 4 group. When we compare GRE between 4 groups, we're using a technique called analysis variance, ANOVA. And ANOVA here, what time is it? We don't. 5 to 5, only 5 minutes. Okay? So I won't talk about, let's not worry about the formula. So long as you know that we formulate an F, it is another statistics. It is the variance between the groups on the numerator. The denominator it is the total variance. Okay? And you standardize this certain way. You want to see how the F looks like. This is not between the total variance. The denominator is the variance within each group. Okay, now we have 4 groups. The within group variance. The between group variance. If the between group variance accounts much more than the within variable, within group variance, then you have a higher chance, a higher confidence to reject the null. That means the 4 mean are equal. So the null hypothesis in the F test is the mu x1 equals x2 equals to x3 equals to x4 bar. Those 4 mean values are equal. That's the null hypothesis. Any violation or shifting away from that H null will indicate a higher F. Okay? The F distributed this. It's skewed to the right. It's had a distribution called F distribution. Okay? And we found these GRE scores were significantly different across the 4 groups of undergraduate